So factoring by product sum and decomposition. So the product and sum method is the idea that if we're looking at this is known as a quadratic, this relationship, and the general form for quadratic looks like this. In its standard form, we'll call it plus bx plus c. Okay, and the key to this is being able to recognize by their position which value represents A, which value represents B, and which value represents C. What we're going to look for the product and sum is we're going to look for the product piece are two numbers that multiply to whatever A times C is. So we actually have to find a product in that process. And for the sum part, those are supposed to be colons, those same two numbers are going to add up to what our B value is, okay? So what we're gonna do is we just gotta do a little bit of calculating to sort that piece. So for our product, two numbers that are equal to A times C. Well, it turns out that A times C would be 3 multiplied by 8, which gives us 24. So in other words, two numbers that multiply to 24, and those same two numbers have to add up to whatever our B value is, and our B value happens to be 14. So just by deduction, I'll tell you that it is easier to find factors than it is to find numbers that sum. There are so many whole numbers that can add or subtract, because you can technically use negative values to get to 14. I could use 14 and 0. I could use 13 and 1. I could do 15 and -1. There's so many of them. Instead, the fastest route to this is just start looking at factors of 24 and see if they fit into the sum piece. So for instance, 8 and 3. Do 8 times 3, that works. 8 plus 3, any version of that, no good. Okay. Another factors of 24. Let's try 2 and 12. 2 and 12, boom, checked it off. There we go. We've figured it out. So that's the product and sum part. You still have to use decomposition. So now that we have this information, we can rewrite the beginning. 3x squared plus 14x plus 8. And the decomposition comes from here. What we now do is we decompose the middle term, or the B term, okay? So the A term is going to stay the same, which is our 3x, oops, that's the wrong level there. Let's put it here. This is still going to be 3x squared, and our C value is still going to be positive 8. Those two things haven't changed. What we now do is we take this number, our 2 and our 12, and we're going to decompose 14x into 2x and 12x. And just to check, does that make sense? Does 2x plus 12x equal 14? Yeah, it does. So we could simplify and go back this way, but instead we've expanded it, and the purpose for making this look a little more complex is for the factoring piece. Now that we've done that, and it doesn't actually matter which comes first, if we had the 12x then the 2x, or the 2x then the 12, you'll still end up with the right answer in the end. You're going to look at these as pairs. So you want to look at this first two as a pair and the second two as a pair, and you want to do some common factoring. So when we take a look at this, for my coefficients, 3 and 2, I don't have a common value. We can use 1. But for my x squared and my x, I can take out an x, okay? So in this case, the common factor is going to be the value of x, so that comes outside. And then we're going to set up a bracket, and after we divide, we're going to leave whatever that is left over after dividing by x in the bracket. So 3x squared divided by x actually leaves us with just 3x. And positive 2x divided by x, well, the x's cancel out, and you're left with just 2, okay? The way we're going to check this is by then doing the same process to the second pair, and the goal is, do we end up with two brackets that are the same? So we take a look at our second two terms. We're looking for a common factor of 12x and 8. Now if I take a look, I can't take any more x's out because there's no x's left. And then, okay, cool. We can take out 4. 4 is a common value for both of these. So if I take 4 out, in this case we take out positive 4, in the brackets what's left over? Well, 12x divide 4, that's actually going to leave me with 3x. And 8 divided by 4 is going to leave me with our 2. So here's our check. Are these two brackets the same? Yes, they are. Okay, we've gone through this process correctly, okay? And then finally, we need to set it up. So technically what we're doing now is we're actually common factoring again. We're common factoring out this bracket here. It's a little complex to look at with a lot of notation. So usually what a teacher will tell you is that on the next step, we just rewrite this. we write this bracket as 1, so 3x plus 2. And then we leave the leftovers, or the common factors here, we put those in the second bracket. Yeah. If you really want to see on the side, so this is it. This would be our final answer here. This is our factored form of this. I can show you, I can quickly show you this piece just so you have an understanding of it. I'm going to do it here. You don't have to do this, where we had our x and then 3x plus 2 plus 4. I'm just going to show you so you understand here. What I do to show the common factoring here is we use a let statement. I'm going to say let y equal 3x plus 2. This will make this question look a lot simpler to us. Okay? This will become x, this part becomes y. So x times y plus 4, and this will become y. Now when we look at it, it looks a little more obvious that, oh, I can factor out y from each of these. So this will become y, x plus 4. But don't forget, y doesn't represent just itself. It actually represents 3x plus 2. And then when we plug it back in, we get 3x plus 2 multiplied by x plus 4. And that's how we get to here. But instead of using this really long process that we showed here on the right, we just usually skip that step and jump to the bottom, okay? And then that's your whole process.